Okay, in this example, a plane flies at a speed of 600 kilometers per hour at a constant height of 14 kilometers. How rapidly is the angle of elevation to the plane changing when the plane is directly above the point 130 kilometers away from the observer? Okay, well, let's draw the situation. So we have like the ground. Okay, this is ground. Okay, and we have the person, let's say right there. Okay, and then we have this plane. It's up here in the sky, and it's flying that way. Here's where the plane is right now. Okay, and we're talking about the angle of elevation up to the plane. Like that. That would be that angle right there. That's the angle of elevation. We're talking about the angle of elevation. Angle of elevation always means from flat up. So that's the angle of elevation. Elevation to elevate, from flat, elevated up, to look at the plane, to spot the person is standing right here and they're looking up at the plane. Their eye, what is their angle above flat, above horizontal, to look up at the plane that's coming at them? Okay, plane flies at 600 kilometers per hour. 600. Oops, that looks terrible. Kilometers per hour. Um, at a constant height of 14 kilometers. Okay, it's interesting. So that means that height right there is 14 kilometers, and it's constant. In other words, the plane is flying horizontally, flying flat, constant height. It's not going up, it's not going down, steady height, 14 kilometers. Okay, and then, all right, well, that's probably enough for now. Let's go to our things we need to do. Step one. Identify or list rate letters. So what are the rates happening here? Okay, plane flies a speed of 600. What is that? Well, you know, um, we could call this X from there to there, there to there, and that dx dt is going down by 600. Right? So that makes it if X is how far on the ground, this is a person right here. If X is how far on the ground from the person to what's directly under the plane, then that's shrinking. Why is it negative? Well, because it's shrinking, it's decreasing by 600 kilometers every hour because the plane's flying like this. And so that X distance is shrinking back. It's getting lower by 600 kilometers every hour. Okay, so that's one rate they mentioned right here. That's the speed. Okay, constant height, that's not a rate. How rapidly is the angle of elevation? So that's what they seem to want from us. D theta dt, that's what they want, right? How rapid is the angle of elevation changing? Okay, that's it. Those are our only two rates mentioned. On we go to number two. Write an equation relating only those letters. No other letters, just those. You have numbers, but no others. X and theta. So we want some kind of equation connecting X and theta. And then numbers. Numbers are fine, but no other letters. Well, I think you know, huh? So if you look at this little triangle right here, um, here's theta. This side over here is the opposite. This is the opposite side. And then here's the right angle. So this side's the hypotenuse, and that makes this side down here the adjacent. So we're thinking about SOHCAHTOA, trig relationship for right triangles. And people always ask me, Mr. How do you know sine, cosine, tangent? Well, I just look at what I have and what I want. I want what x and theta. So here's x, that's the adjacent theta, of course, and I know the 14. I'm not going to use the hypotenuse at all. Why? I don't know anything about the hypotenuse. I don't want it. I don't have a letter there. I don't have a number there. I don't have anything there. I just have x for the adjacent and 14 for the opposite. So opposite and adjacent. What trig formula has opposite and adjacent? Tangent. So that means I'm going to go, oh, okay. So that means tangent of theta. Tangent of that angle theta is opposite over adjacent. It's 14 over x, because that's opposite over adjacent. So there's a relationship between theta and x, and numbers are fine, but only those two letters, theta and x and theta. Okay, got it. Step 3, d dt. Both sides take the derivative with respect to time of both sides. So d dt this side and d dt that side. Well, actually, okay, what's the derivative? Tangent, secant squared, theta times, the inside is not an x, so it's d theta dt equals, now this side, I'm going to actually write this as 14x to the minus 1. And then I'm going to take the derivative. So the derivative will bring down the minus 1, so it'll be minus 14x to the minus 2 times dx dt. Yeah, I shouldn't have said because it's not a t. So anyway, chain rule. We got to do the chain rule in both cases. So there we go. That's our related rates. This is how the rate dx dt relates to the other rate d theta dt. There we go. Now, now we step 4, plug in the numbers. Plug in the numbers. Okay, do we know theta? Well, do we know x? How about that? Yeah, we do know x. It says right here, it's another fact I haven't used. When the plane is directly above a point 130 kilometers from the observer. So we want x to be at this snapshot in time, right? The plane's flying and we watching a video and we freeze the frame, snapshot, when the plane on the ground is 130 kilometers away from the observer, right? To the plane when the plane is directly above a point 130 kilometers from the observer. So the plane's right here, directly above this point, which is 130 kilometers from the observer, the person. So, okay, so x is 130. So that means we can also find tangent of theta is 14 over 130. That's opposite over adjacent. Now that we can put in the 130. And so that means theta is, so then you're going to take inverse tan both sides. So theta is inverse tan 14 over 130. There's theta. So, okay. So now, coming on down here. Oh, yeah, what do we always do with secant squared? We move that to the bottom. That's going to be 1 over cosine squared of theta. D theta dt, right? Because secant, remember that trig relationship? We have sine, cosine, tangent, flip, flip, flip. Remember, if you flip, 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 you get cosecant, secant, cotan. So secant and cosine are the flip of each other. So secant squared, flip that, okay? And let me just rewrite this stuff. Okay, so yeah, what are we gonna do? It's a bit of a pain, but we can do it. So we've got this theta is inverse tan of 14 over 130. So we're going to say, okay, it's a little bit ugly. Need some more space here. So, okay, so this is 1 over, so funny looking 1. Okay, 1 over cosine squared of, and what's theta? Well, it's tan inverse of 14 over 130, like that. It's a little weird, isn't it? But that's correct. Times, because that's what theta is. Theta is tan inverse 14 over 130. What's d theta dt? Well, that's what we're looking for. Trying to find d theta dt. Okay, minus 14. What's x? We found x somewhere, didn't we? Oh yeah, x is 130. So that's going to be 130. So it's 2 times dx dt. And dx dt is right there, minus 600. Minus 600. All right. And we're solving now for d theta dt. Woo. So that means we're gonna need to multiply to get d theta dt alone. We're gonna need to multiply both sides by cosine squared of tangent inverse of 14 over 130. Boom, boom. Same thing over there. So then d theta dt, and multiply on this side too, and over here, times cosine, yeah, messing this all up, cosine squared, tan inverse, 14 over 130. Wow, so this will be minus 14 times 130 to the minus 2 times negative 600. It's hard to believe that, this is going to come out right. Just try to be careful not to mess anything up. Times cosine squared, tan inverse, 14 over 130. Wow. Let's go type that in. Desmos to the rescue. So, um, minus 14 times, let me go see. We have minus 15 times 130 to the minus 2 times minus 600. 130 to the minus 2, 130 to the power minus 2 times minus 130 minus 2 power, 130 minus 2 power, minus 600 cosine squared, minus 600 times. Okay, now we're going to need to do parentheses, cosine of, going to function tan inverse. Who is this something, huh? Tan inverse of what? Was it 14 over something? 14 over 130. And then that's squared. 14 over 130. Um, Squared. Is that right? Yeah. Here we go. So we had to, so that's a lot of parentheses, isn't it? 1, 2, 3, 1, 2, 3. Yeah. That whole cosine had to be squared, you see. So there we go. Oh, well, no, I'm in, oh yeah. Watch out. See, now there's degree mode or radian mode. So I'm in radian mode. Everything's going to be radians. Well, I guess it doesn't matter in this case. Yeah, because those aren't angles. Yeah, doesn't matter. Anyway, 4913. I'm getting 4913. Is that right? 4913? Oh, yeah, it is. That's beautiful. 4913 radians per hour. It'll automatically be radians per hour. That's how fast that angle is changing. We got it. That was quite a mess. There we go.